Okay, so what we're going to start with is dividing our periodic table up into blocks. So let me zoom in here. And I'm going to use a variety of colors to do this. You may do the same. And first block I'm going to identify is right here. It's the first two vertical columns of your periodic table. And it's also over here on the right, this one lone box up there. Now the name for this block is called S block. They are the S block elements. So maybe down below here you can write S block so you remember. The next block that we're going to identify is one in the middle of the periodic table, and it's called D block. So I'm going to outline 4 elements tall, 10 elements wide. This whole group of elements here is called D block. And you can either write it above it or below it, your call on that. D. Next, we have this big square over here on the right, and it's 6 tall and 6 wide. And this one here is called P block. And last but not least, we have these elements on the bottom down here, and they're offset from the rest of our periodic table. There's no physical connection there, and we'll explain why a little bit later. And this is called F block. Okay, so now we have 100% of our elements covered by a particular block on the periodic table. I want to focus in on the top left of the periodic table right now, and really to the left of the periodic table in general. And up here, I'm going to write energy level. Energy level. And what I'm going to do is I'm going to go down the left-hand side of the periodic table, and I'm going to number the energy levels present in the periodic table. It goes like this. 1, 2, 3, 4, 5, 6. So you have 7. 7 energy levels from top to bottom down the left-hand side. That's going to come into play a little bit later. Next, we talked about this being a type of coding for every element in terms of the electrons that it possesses. So what's going to happen here is I'm going to draw a model of a block. Okay, this is just any old square, a square. This is a square from the periodic table, and it's going to happen to be my first element. And what I'm going to do is the first thing I'll put in here is a 1. The second thing I'm going to put in here is the lowercase letter s. And the third thing I'm going to put in here is a little number 1, but I'm going to superscript it up to the right. So let's identify what is involved with coding a particular element. The first thing we have to be putting into a square is the energy level, and that's what that 1 is. So energy level 1. S is considered a sub-level. If you'd like, you can put block in parentheses. And the little number here, the 1 in this case, is the number of electrons in sub-level. Number of electrons in sub-level. Okay? So every single element is going to have this coding system that represents it. And what we're going to do is we're going to code the entire periodic table in the next, less than 20 minutes. and we're going to tell you exactly how to write an electron configuration for a given element. Okay? Alright, so let's start at the first element, which we've already done in our big sample box here. So the element hydrogen is coded as 1s1. Why? Well, it's an energy level 1, it's part of S block, and it's the first electron in S block. Now, because we read the periodic table left to right, top to bottom, I got to skip over all this empty space here, all the way over to that element, which is element number 2, helium. Helium is in energy level 1. It's still part of S block because it's outlined in orange in my case. And it is 2 for the number of electrons. There's 2 electrons in the sublevel for 1s. The first electron was in hydrogen's box. Now the second electron goes with helium. And as you recall from helium, it's atomic number 2, which means it has 2 protons and how many electrons? 2, because it's a neutral atom. Then, because we're reading top to bottom, left to right, we get to the second energy level, or the second row. So we're going to start with the number 2. We're still in S block, so it gets an S. And this is going to be the first electron in energy level 2 S block. And this is the element lithium. The fourth element is called beryllium, but its coding is that it's still in level 2. It's still in S block, and this will be the second electron in 2s. Then you see that there again is a big open space here, so we're going to go ahead and bypass it, and we're going to enter over here. Now here we have a new block. We have P block, but we're still in energy level what? 2. So we have 2P, and because this is going to be a brand new sublevel, that's the first electron that goes in this sublevel. So 2p1 restarts the count again. Then, next element, that would be boron. Next element's carbon, energy level 2, p block, and 2 electrons. For nitrogen, we have energy level 2, p block again, 3. Oxygen 2p4. Fluorine 2p5, and neon 2p6. Every time we change elements, we go up a number in our electron count for that sublevel. So we've reached the end of the row, and now we're back to energy level 3. And I think you can probably, by logic alone, being able to spot patterns, predict what's going to be in this next box. What do you think? 3s1, very good. Second box? 3s2. Ah, we can spot patterns. Alright, so let's jump over that big open spot here. And what would you expect to be in the next? Oh, 3p1. Followed by 3p2, 3p3, so forth and so on, all the way till you hit the end of this row. Now, this next row is going to have something interesting happen. Everything starts off like logic would tell you. So what would you expect in the first box? 4s1. Okay, 4s2, no problem, would be in the second one. Now, something very strange happens as you enter D block. For some reason, which we'll explain a little bit later, we would think, just by pattern so far, that 4d1 would go in the next box. Okay, that would make sense. But remember, sometimes we got to think outside the box, and we have to be able to accept patterns as they come to us. What actually winds up in the next block here is 3d1. So it goes down a level. For some reason, when you're in D block, you go down a level after your original level that you started at. So you start with 3d1, you follow 3d2, 3d3, and you go all the way to the end of D block. So I'll let you do that right now. Keep filling them in, adding 1 electron at a time until you get to the end of D block. Now, after you reach the end of D block, something weird happens again. It goes right back to the original way we were doing it. So instead of staying at 3, we go back to energy level 4. And it's like it never happened. 4p2, 4p3, 4p4, all the way to the end. Alright, time for a little logic for the next full row, left side to right side. First box, what are you expecting? 5s1, no doubt, and then 5s2. Now, based on the pattern involving the middle D block elements, what do you think might be in that first blue box? The D, 4d1. Good. 4d1, 4d2. You're going to go all the way from left to right, coding each one as you go. And can we predict what our next element would be in P block? Yes, 5p1, and code all the way to the end of P block. All right, another strange thing is about to happen, okay? Every one of the rows starts off normal. So what would you expect in the first box here? 6s1 and then 6s2. No problems there. Now, here is the deal. I'm going to pull this off for a second, and I'm going to show you what a periodic table is actually supposed to look like. Okay? Look at this periodic table. That looks a little different than yours because there's a whole subset of elements down there. But nobody could fit this on an 8.5 by 11 piece of paper. There's too much stuff from left to right. So what they did was they offset it. And what I mean by that is if I grab a regular periodic table, exactly the same one that you guys have, you're going to notice that elements 57 to 70, if you look right here, I'll zoom into the spot. Right now we're here with 6s2. Then you see it jumps from 56 to 71. But where does it go? Well, 57 to 70 drops down to here. So what is going on here is we had to place them down below because we couldn't fit it on a piece of paper. So what that means for us in terms of our design here is we're now going to drop down. And if you want to draw a little arrow like this, you can. If you can remember it, that's fine too. But again, with the whole number thing, something bizarre is going to happen. So far, we've been dropping 1 in D block. We're going to drop 2 in F block. So what we're going to get down here is 4F1. Remember, we're in F block. 4F2, 4F3. And we're going to go as far as we can go with F block. Do that right now. How many did you wind up fitting? 14, right. And then when you hit 14, strangely, we jump right back to where we were before. Right to here. And what would you expect to find in this box? 5D1 is right. 5D2, and we're going to go all the way across until we can't go any further in D block. That gets us to 10 again. And then just like back to normal, what would you expect in the block after the 10th element in D? So what would be your first P element in this row? Yep. All right, one more row to go. One more energy level, 7. Okay, everything starts out the same, 7s1, 7s2. Now, where do you think I go after 7s2? Yep, back down to F block down here, And what number do you think I'm going to get to if we have to drop 2? Exactly. 5F1, 5F2. And I'm betting that a lot of you could probably finish off the rest of the whole periodic table without me saying a word. Okay, after 5F14, we jump back to D block. Anybody want to guess what is their first coding of D block? 61, correct. And our last 6, go back to number 7. And we are officially have coded by way of electrons every element on the periodic table. Now, here is what you're going to be asked to do. Electron configuration codes out every element with a specific number, letter, and then a number superscripted to it. So you could locate any element I tell you to. Like if I said, what is the code for nickel? Take out your regular periodic table and see if you can find me the code that nickel's electron configuration ends on. If you don't have a periodic table that I gave you, why not? Why do we not have that here? It's a chemistry class. 3D8. Correct. It's in D block. It's 3D8. What if I asked you to find the element calcium? What is the electron configuration code that calcium ends on? 4s2. How about platinum? People like platinum a lot. What was it? 5D8, correct. How about some good old, Einsteinium? We gave some tribute to Einstein during this chapter. Let's find the element that has his name in it. Einsteinium. What is it? 5F? 5F10, very good. 5F10 would be Einsteinium. Now, maybe you picked it up, maybe you didn't, but I said the electron configuration that a certain element ends on. So what that means is that it's not a complete picture of the electron, of the particular element. So what we're going to do is we're going to learn the coding system, how to write down the code up to and including a particular element we choose. Like, let's say, for example, I wanted to write the full electron configuration of neon. Okay, everybody find neon on a regular periodic table. I'll give you a hint. It's a noble gas. Everybody find it? Okay. Now, we can't just straight up write neon out. Okay? 2p6 out. What we have to do is we have to get there. And what I mean by that is we have to mark certain locations that we have been to on the way to neon. So we always start off at the very first element on our way to some element. So we read it left to right, top to bottom. And I'm going to give you some places that I want you to maybe put a little dotted circle around certain configurations. For example, on my way to neon, I know I have to start reading the periodic table like this. Left to right, top to bottom. So I go in this kind of direction. Now, anybody remember the story of Hansel and Gretel? No? No one knows it? What did they leave in the woods to find their way back home? Breadcrumbs, right? So in a way, we're going to be dropping breadcrumbs so we know where we've been as well. Okay? The first one I'm going to drop on the way to neon is right here, 1s2. Because that's the end of S block in the first energy level. The second place on my way to neon is going to be here, 2s2. Because it's the end of the second energy level S block. The third thing I'm going to write down for neon is, and happens to land right on neon, is this configuration right here, 2p6. So how I would show the electron configuration of neon is like this. I'd write its symbol, Ne, and then I would put all those places that I noted on the way there. 1s2, 2s2, 2p6. That is neon's electron configuration. 1s2, 2s2, 2p6. All three of them. Now, what if you had an element that was further down? Like, let's say the first one I gave was nickel. Remember that? Okay, so if I was to find nickel, I go back to what I started with. I always start at the first element and I travel there. Okay, so the first one I'm writing down is 1s2, 2s2, 2p6, but then I keep going because that only gets me to neon. So the next place I'd write down is 3s2 because that's the end of energy level 3s block. Again, a big open space. Then 3p6 because it's the end of third energy level p block. I'm not there yet because 3p6 is argon. Next place I'm dropping a breadcrumb is 4s2 because the last element of S block, fourth energy level. And then where was nickel again? 3d8. The last place I note is the actual electron configuration of the element I've chosen. So in this case, nickel, and I can even circle it for our purposes here, how I would show that as electron configuration is I'd write the symbol out, Ni, followed by the electron configuration that got me to nickel. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and finally 3d8. That is the total electron configuration of nickel. You have to list out every one of those key spots that you pass on your way to that element. Okay? Well, what if I gave something real tough, like tungsten? Everybody find tungsten. I'll tell you what, it's in D block. Everybody find it? It's got a weird symbol for a word like tungsten. W, right? All right. So let's say that was your element you had to do. You know you're going to start with the element symbol here. And what you're going to do is you're going to go back to the start of the periodic table, just like every time you do one of these. And again, you're going to list out all the places that you drop these breadcrumbs at on your way to tungsten. Now, this one is tricky, and let me tell you why. All of these remain the same. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. But I'm bypassing nickel now. And instead, what I'm going to do is I'm going to note on my pathway to tungsten the last element of energy level, in this case 3, and the 10th element. I keep going because I'm not even near tungsten yet. 4p6 I'm going to be able to jot down. 5s2 is next as I read my periodic table left to right, top to bottom. After that, 4d10. Next, 5p6. I'm still not there. What did you say tungsten ended on? 5d4, right? So that means 6s2 gets written down on the way there. Now, where do we go after 6s2 again? Down to F block, right? So we also must note the last element of the 4F sublevel on our way there. Then it jumps back to the periodic table here, and we end on 5d4. Okay? So the only weird step in that one was after we got to 6s2, we dropped down, and because the atomic numbers keep going up one at a time, from this point forward, we mark that one, then we go back, and we hit the element dead on. So what do we write on our paper? All of that. Okay? All right, so let's focus in and let's jot down all those places we stopped from left to right, top to bottom. Started with 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. Are we all together on that top row? Okay. Where'd we go after 4p6? What was the next one we got to mark? 5s2. Then what? 4d10. Let's keep going. 5p6. Yup. Then 6s2, then, very nice, 4f14, and then lastly, 5d4. Okay, that big old thing right there is tungsten's electron configuration. Okay, so that is what you would write down if someone wanted to know the electron configuration for tungsten. Now, again, this is a coding system. Every element is coded not only by an electron configuration that it ends on, but the build-up to get there. And you'll notice there's a pattern, again, in the pattern recognition. Look at all my S's. Those are all stopping points on the way to certain elements. All my D's. These are all stopping points that need to be written down. All my P's. Okay? And all my F's. 14s. Okay? All of those little stops on the way to your element are necessary when you write an element's electron configuration. All right. We're going to practice this today.